SQA National 5 Maths 2014 Paper 1 Question 1 said, evaluate 5 over 12 times 2 and 2/9. So I've got to multiply fractions, but I've got a mixed number. So when you try to times with a mixed number, the easiest way to do that is to change the mixed number to an improper fraction. So I'm going to keep the 5/12 where it is, but I'm going to times by, well, it's 2/9. 2 times 9 is 18. 18 plus 2 is 20, so it's 20 over 9. And now I can do the times. I can times the top and times the bottom, or if you prefer, you can simplify in advance. I'm just going to go ahead and just times and then simplify at the end. So I'll do 5 times 20, which is 100, over 9 times 12. Now, if you don't know what 9 times 12 is, at the side, 12 times 9. 9 times 2 is 18, carry 1. 9 ones are 9, plus 1 is 10, so you get 108. So far, so good, but you have to simplify all answers. I can see they're both even, so I can divide by 2, or you can find a bigger number if you can. I'm just going to divide by 2. So if I imagine splitting that up and say divide by 2 and divide by 2, that gives me 50 and 54. I can keep doing that, so I can divide by 2 and divide by 2 because they're still both even. That gives me 25 and 27. And now you need to check, is there any numbers that go into 25 and 27? Well, the only numbers that go into 25 are 1, 25 and 5. And 5 doesn't go into 27, so I'm done there. SQA National 5 Maths 2014 Paper 1 Question 2 on expanding brackets. Multiply out the brackets and collect like terms. But a standard one this, so we've got a box. 2x minus 5 on one side and 3x plus 1 on the other. Split it into 4 and begin. 3 times 2 is 6x squared. 3 times 5 is 15, but it's minus 15x. 1 times 2x is plus 2x. And 1 times minus 5 is minus 5. Usually get a mark if you get that far, then collect like terms. So outside the box, you've got 6x squared. These two go together, so being careful, minus 15 plus 2 is minus 13. X, and then minus 5 on the end. And we're done there. SQA National 5 Maths 2014, Paper 1, Question 3 on completing the square. Express x squared minus 14x plus 44 in the form x minus a squared plus b. So all you do is you open a bracket, it's x minus a. So if you notice, the middle term is 14, so I divide that by 2 to get 7 squared. I immediately take away that squared, 7 squared. And then it says plus 44 in the end, so I keep that plus 44. So there's your method. Then we just work out our 7 squared, so it's x minus 7 squared. Take away 7 sevens is 49 plus 44. Being careful with my negative numbers here, that gives me x minus 7 squared. Minus 49 plus 44 is minus 5, and we're done there. SQA National 5 Maths 2014, Paper 1, Question 4 on vectors. Find the resultant vector 2u minus v when u is this vector and v is that vector. So 2u means we just times each number by 2, and then we take away v, so we take away the top, the middle, and the bottom. So let's work out 2u. So 2u is equal to 2 times minus 2 is minus 4, 2 times 3 is 6, 2 5s is 10. So that means that 2u minus v is equal to minus 4, 6 and 10. Take away 0, minus 4 and 7. Minus 4 minus 0 is minus 4. 6 minus minus 4, that's plus, so it's 10. And 10 minus 7 is 3. It says leave your answer in component form. That is actually component form, so we're done there. SQA National 5 Maths 2014, Paper 1, Question 5. This time on the sine rule, unusual for a non-calculator paper, but it does happen. So checking the start of the exam paper, we've got a over sine A equals b over sine B equals c over sine C. Now you might be wondering, how did I know that this was the sine rule? So let's see how I knew this in advance. I've already actually looked at this question. We have got sine k is 0.4. So the sine of this is 0.4. Let me just write that here. Sine k equals 0.4. And sine L equals 0.9. So we've got sine and sine, and we have to find the size of LM, which is over here. So let's just call that little k maybe. And opposite, opposite is the sine rule. So let's just substitute everything we've got in. So we've got k, I'm going to call my missing side k, over sine k equals 18 over sine L. Now be very careful here. Common mistake that people make is they see I need to do sine k and they somehow write down sine 0.4. Now it's not for a non-calculator because it's not an angle they've given you. They've given you the whole of sine k, so you just write 0.4 down for sine k, and they've given you the whole of sine L, so you just write 0.9 down. So in other words, you write k over 0.4 equals 18 over 0.9. And then we need to rearrange and work out for k. This is a non-calculator question, so since 9 goes into 18, I might as well work out this side and leave k over 0.4 until the end. So I've got k over 0.4 equals, well, 18 divided by 9 is 2, so divided by 0.9 is 20. If you're not sure of that, you just times this by 10 to get 180 and times that by 10 to get 9. 180 divided by 9 is 20. And now I can work this out. That means that k equals 20 times 0.4. So again, a non-calculator bit of work. I do 2 times 4, which is 8. And that means that I've went 10 times bigger and 10 times smaller, so the answer is just 8. If you don't like that, at the side you can do 20 times 4, which is 80. But then that means 20 times 0.4 is 10 times smaller, which is 8. So the size is 8, and the units are centimetres. So we're done there. On to line of best fit. This is basically a straight line question, but it comes in the stats topic because it uses real world data. So it is all just straight line with a little extra bit on. Let's look at one of the questions. 2014 National 5 Maths, paper 1, question 6 had this one. McGregor's Burger sells fast food. The graph shows the relationship between the amount of fat and the number of calories, fat in calories instead of x and y, in other words. Part A, find the equation of a line of best fit. Well, it's just the same as straight line. We need a point and we need the gradient. So let's find the gradient first. Let's see if we're given any points. Way down, right at the bottom, it says point A represents 5 grams of fat and 200 calories. And point B represents 25 grams of fat and 500 calories. So our 2 points that we've got are 5 and 200 and 25 and 500. So for question A, to get the equation of a line, well, we need the gradient, which remember is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. That gives me 500 minus 200 on the top, 25 minus 5 on the bottom. Non-calculator, so that gives us 300 over 20. Well, that gives us 15 as our gradient. And we've got a mark there for getting 300 over 20 or 15. Part B, next part of the question, I always use y minus b equals mx minus a, where a and b is a point. So let's just pick the first point, a and b. You could have picked the other one. Subbing that in, you get y minus 200 equals 15, x minus 5. Tidying that up, so it says y equals. You've got a mark there just for getting this, so you get y minus 200 equals 15x minus 75. 5 15s. Y equals, move the 200 across, 15x plus 125. And usually with a straight line question, you'll be done there. But this is worth 3 marks, and you get a final mark for swapping the y and x for the proper terms. So in this question, y is c for calories and x is f for fat. So I switch the y for c equals 15f plus 125 for my final mark. Let's move on to part B. Part B says a super deluxe sandwich contains 40 grams of fat. Use your answer to A to calculate the calories. So we're just substituting 40 in for F. So for part B, F equals 40. So C equals 15 times 40 plus 125. A little bit of work to do 15 times 40. So 15 times 40 you've got 0, 4 5s is 20, 4 1s is 4, 5, 6. So C equals 600 plus 125, which is 725 calories. And we're done there. SBA National 5 Maths 2014, Paper 1, Question 7 on quadratic graphs. The diagram shows the part of the graph y equals ax squared, and it gives us a point. We have to find the value of a. So whenever you've got a point on anything, you need to realise a point is an x and a y. So if I write this is x and this is y, well, I've got an equation with an x and a y and an unknown, so I can just substitute in to find my answer. So y equals ax squared is what I'm starting with, but x equals minus 3 and y equals 45. So we're just subbing the values in. So 45 equals a times minus 3 all squared. 45 then equals a times minus 3 is 9. So that means I can say that 45 equals 9a. Divided by 9, 5 equals a, or a equals 5 then. And we're done there. Little past paper question, 2014, paper 1, question 8. Root 40 plus 4 root 10 plus root 90 as a surd in its simplest form. Can't add them until we're all simplified. So let's start with root 40. So we've got root 40. Well, that's just 4 times 10 to root 10. Notice how root 10 has appeared, and we now know that root 10 is already simplified because 4 is the biggest square number. It goes into 40 and it gave us root 10 as an answer. So I don't have to try and simplify my root 10. So I'll now go and simplify my root 90. Well, that's 9 times 10. Square root of 9 is 3, so that gives us 3 root 10. So our whole sum simplifies into 2 root 10 plus our 4 root 10, it was already there, plus an extra 3 root 10. So adding all them together, 2 plus 4 is 6, plus another 3 is 9. Our answer is 9 lots of root 10. Okay, same type of question here, but this time non-calculator. I can't use a calculator at all. So it's 2014, paper 1, question 9. This was from 480,000 tickets were sold for a tennis tournament last year. This represents 80% of all available tickets. Calculate the total number of tickets that were available for this tournament. I know that 80% represents 480,000. And I want to know what's 100% going to be. So I need to get down to 1% maybe, or 10%, and then back up to 100%. In this case, I can see that 80 does go into 480,000, so I'll find 1% by dividing by 80. 480,000 divided by 80. So I can knock a 0 off straight away. 8 6s is 48. 1, 2, 3 zeros left over. So I've got 6,000 for 1%, and therefore 100%, just times them by 100. Making sure I get all my zeros in, 600,000. And there we are. Next grade National 5 Maths 2014 paper 1 question 10 had this graph. It's an a sine x plus b. So again, the amplitude is when up to 3 and its lowest point is minus 3. So a is just 3 for 1 mark. And to get our b, well, if you've got this bracket x plus, it means it's shifted to the left or right. Plus for left, minus number for right. So normally the sine graph starts at 0, but it's been shifted 40 degrees to the right to start at 40. So since it's been shifted to the right, b is minus 40, not positive 40. That's the 5 Maths 2014 paper 1 question 11 says a straight line has equation 4x plus 3y equals 12. Find the gradient of the line. Well, that's quite easy then. So we just rearrange it to make y the subject. So we've got 4x plus 3y equals 12. So taking the 4x over to the other side, we get minus 4x plus 12. Dividing through by 3, we get minus 4 over 3x. Plus 12 divided by 3 is 4. And then stating our gradient, m must equal minus 4/3. And we're done there. Part B says find the coordinates of a point where the line crosses the Part B says find the coordinates where a point crosses the x-axis. So we've got 4x plus 3y equals 12, remember. Cuts the x-axis when y is 0. So we've got 4x plus 3 times 0 equals 12. So 4x equals 12. So x is 12 divided by 4, which is 3. So the point is 3, 0, x and y. It's grade answer 5 Maths 2014, paper 1, question 12. Pythagoras in circles. This one, it says the radius of the circle is 15. A is the midpoint of chord PQ. There's PQ there. And the length of AB is 27. The length of this is 27. Calculate the length of P to Q. So to calculate the length of this P to Q, if you're doing lengths inside a circle, usually it's Pythagoras. So you try to make a right angle triangle and use the radius to help. So I could make a right angle triangle there, or I could go the other side and make it there, and it'll make no difference because it's symmetrical. So I'm just going to draw in a random line. There we go, and now we've got a right angle, and then see if we've got any information. So it says the length of A to B is 27, and the radius is 15. So marking my radius first, that is 15. Now this whole length is 27, so let me just show you that. That's 27 from there to there. But I know the radius from here to here is 15. So that means that I can do 27 take away 15 to get the size here. So that's 15, 25, 26, 27 is 12. So I now know this is 12. And that means that since A is the midpoint, if I work out this side here, let's just call it x. If I double that, I'll have the length QP. Now, do we need to add or take away is the next question for Pythagoras? Well, once you've found your right angle, the opposite side is always the longest length. So 15 is longest length. I've already got that. If you've got the long side, you're taking away. So all I need to write is that x squared equals 15 squared minus 12 squared. Doing a bit of work without a calculator, 15 times 15 is 225. You need to work that out yourself. 12 times 12 is 144. So I do the two sums. X squared equals, now if you don't know the answer to that sum, or you can't do it in your head, just take a little time. 5 minus 4 is 1. Can't do 2 take away 4, so I'll borrow to do 12 take away 4. 12, 11, 10, 9, 8. And then 1 take away 1 is 0, so x squared is 81, which means that x is the square root of 81, which is 9. So my length of x is 9, which means that PQ is equal to 2 times 9, which is 18. And the units were centimetres, so I'll put my units in just to be on the safe side. It's grade answer 5 Maths 2014, paper 1, question 13. The diagram below shows the path of a small rocket, which is fired into the air. The height h of the rocket after t seconds is given by 16t minus t squared, which is a quadratic, and you can clearly see a parabola there. After how many seconds will the rocket first be at a height of 60 metres? So for part A, it's telling us that h equals 60. So I'll just sub that in. I've got 16t minus t squared equals 60. So moving everything over so that it equals 0, I'll move it to the right so I get a positive t squared. So that gives me t squared minus 16t plus 60 equals 0. So all I've done is I've moved the minus t squared over to make positive t squared, and I've moved the 16t over to make minus 16t. I've now got a quadratic to solve, so I look for a common factor. There isn't a common factor, so I'll try and factorise it. Now, if it doesn't factorise, I'll use the quadratic formula. But it is paper 1, so chances are it will factorise. So double brackets, t and t. I'm looking for two numbers at times to make 60, but add to make 16. So I can make a little table with myself, 16 and 60. So 1 and 60, that doesn't work. 2 and 30, that doesn't give me 16. 3 and 20, that doesn't give me 16. 4 and 15, well, that doesn't give me 16. Eventually you'll get to 5 and 12. 5 times 12 is 60, but 5 plus 12 doesn't work either. And then you'll get to 6 and 10. And eventually 6 and 10, 6 tens are 60, plus 6 plus 10 makes 16, but we'll try to make minus 16, so it's minus 6 minus 10. Minus 6 minus 10. Now you might have got there quicker, and if you did, well done. That means that t equals 6 or t equals 10. So at first, after how many seconds will it first be at a height of 60? The first one's 6, so our answer is t equals 6 seconds, and we're done there. So we highlight it and underline it. It now says, will the rocket reach a height of 70 metres? Well, the maximum it ever is the maximum turning point, which is here. So we need to work out where the turning point is and then find out whether or not at that turning point what the height is. So we know we've got 6 and 10. So for part B, our turning point happens at 10 plus 6 divided by 2. You add the roots and you half it to get the middle of them. 10 plus 6 is 8, divided 10 plus 6 is 16, divided by 2 is 8. So the turning point happens at 8 seconds. So when t equals 8, we have got h of t is 16t minus t squared. So when t equals 8, we've got that equals 16 times 8 minus 8 squared. That's 128 minus 64, which equals 64 meters. So then we'll just write a little statement. Max height equals 64. So rocket never reaches 70 meters. And we're done there.